Okay, so in today's class, we'll be talking about load balancers. We'll be talking about how to distribute the load amongst various machines. What are the various algorithms that can be deployed for the same? And how do we handle high amount of traffic inside EC2 instances? Now, the concept of load balancers and your auto scaling groups and basically scaling up or scaling down is rather handled via your Dockerization services. By that, I mean either it will be ECS or it will be EKS in this case. So that is how basically you will go and handle the load on the machines or high load on the machines. So easier answer is you could have gone for your Fargate instances, and Fargate instances are basically the serverless instances that will automatically scale up to suit your need. So these things were pretty much prevalent back 2 years back or 2 to 3 years back, whatever we are talking about load balancing and auto scaling. Uh, Another reason for that is Kubernetes deployment itself has various strategies, and one of them is the load balancing strategy in itself. So in this case, inside Kubernetes itself, you automatically have the algorithms or you have the deployment strategies available, which will automatically deploy the things to your machine, or it will automatically scale up the load for you. So in this case, it is not that greatly used now. So any companies which are starting with AWS now generally prefer straight away going to ECS and EKS, and they generally prefer using the deployment strategies which are for ECS and EKS itself. But still there are ample amount of companies, and actually let's be honest, it is almost around 60 to 70% companies, those who are still working on the instances and on the load balancers. So if in case you are working on them, in that case, you will be using the strategies that I am going to talk about today. Okay. Just a minute. Okay, so let's get started. So what we'll do is we'll be talking about the load balancers, and we'll be talking about the web servers, and we'll be talking about how to install the web servers. Also, anyone who is joining, please switch off your video straight away. Okay, please don't open your camera, and yeah, that will actually help us in not getting disturbed. Okay, fine. So what we'll be doing is we'll be creating a few instances, and we'll be going and running or installing the web servers inside that, or we'll be installing rather the softwares for running the web servers, which in our case will be Apache. Though you might have used your Nginx server also, you can use Apache itself. You have various options. The most preferred one, what is used, is our Apache web server. So that is the one that we are doing. So the prerequisite to start is that you should at least know how to create or launch a server. You should at least know how to go and install the basic web server or Apache web server inside your machine. That anyhow we have already done in the yesterday's class. And those of you who were in the previous patches, you would already be knowing that. So what we'll do is we'll go and create 4 instances straight away, and we will install the web servers inside them, and then we will create the images out of them. After that, we will be starting the load balancers. So having said that, let's straight away go and launch 4 instances over here. Okay, because this is a webinar, so in case if any one of you will cause any sort of disturbance, I'll straight away kick you out of it. Okay, so please don't interfere in the class at least. Okay, this one, I'm calling it as instance 1. Next one, why we are doing it like this? Because actually you see, I want high availability, and high availability means the instances should all be in different AZs or different availability zone. So I already have one in 1C. What I'll do is I'll also go and create one in 1A and one in 1B. And this one I'm taking T3A micro. This one I'm calling it as, or let's call it as 1A itself, because this one is in AZ of 1A. This one is in AZ of 1C. So I'll be naming it as 1C. And the next one, we'll go and name it as 1B, because we'll be putting it inside 1B. Again, I won't bug your time by talking about why am I doing or installing it inside multiple AZs or multiple availability zones. We already know the answer that if a region goes down and all those things. So in that case, at least my high availability will be maintained. Uh, Contrast, or if you want to draw a similar contrast with this, you can take help of your subnet groups which you created inside any of the database services of AWS, either your DAX cluster or your DynamoDB or your Elasticache or your RDS. So, okay, let's not go into RDS right now. Let's talk about DAX, DocumentDB, Elasticache. In these case, in these databases, basically, I had the concept of the subnet group where I had created a cluster, and that cluster was having a specific size, let's say 3 instances. Then I said that I'll be creating the machines in 1A, 1B, and 1C, which means ideally it is equally distributed into 1A, 1B, and 1C. So that was the thing. Now I don't have it inside Amazon key spaces and not inside DAX, but inside DynamoDB. So nothing in key space, nothing in DynamoDB, because that is automatically managed by AWS themselves, which basically means that in this case, our instances are automatically replicated to multiple AZs. In that case, we anyhow don't have the concept of AZs itself. Rather, we have the concepts of the reads and the writes, or the IOs, or the input and the output of the machines. Finally, going to RDS. In RDS, we don't have the concept only because the reason is in RDS, you always have a single instance, or and if you want, you can have a standby instance. So in at max, you can have 2 instances inside RDS. Yes, you can create a read replica, but the word itself is saying it is a read replica. So in this case, again, you cannot have this concept. So where do we use this? Now, the concept here is that in case we have to go and we have to create a database out of our own cluster. This, by the way, will also be your interview question and your interview thing that you are going to tell over there. We will be creating this in the next class or in our weekday class, where we'll be creating our own database cluster of a NoSQL database. Preferably, we will be choosing MongoDB. The advantage of that is, in that case, I don't have to go to database and worry about the document DB. Rather, I can create my own instance of DocumentDB. There are various advantages to this approach. Advantage number one is when you launch the instance, there, if you remember, your DocumentDB only has a specific instance type, which are primarily the R5 instances, the R6 instances, and the T3 instances. That's it. You don't have any other option. Second, if in case you are creating an instance inside your document DB or even inside your RDS, you don't have all the volume types option which are available. By that I mean you only see GP2 over there, you only see IO1 over there, and you only see standard over there. You do not see GP3, you do not see IO2. And if you know it, you know it that GP3 will save 80% of my price. Secondly, GP3 is faster than my GP2. Why? Calculation wise, we have already done that. Again, not dwelling into that, but we do know that I don't have only GP3 options inside the machines over there. The same case applies for RDS. This is two of the things. Next, if you are launching your database inside the instances itself, the advantage you can have is you can have a snapshot. You can take a backup of your volume itself, of your instance itself, and more than that, you have concept of a life cycle manager, wherein you could have gone and created your own EBS or your own AMI backup, which was a snapshot. You could have even copied it to a different region, and you can configure up to 4 schedules over here. Now, if you need more than 4, you could have always gone and created multiple lifecycle manager. The advantage of this is more into your control if you are creating the database cluster yourself. Why we are going a lot into the cluster today? Because when we talk about load balancer, a load balancer in itself is nothing but a cluster itself. So a load balancer will ideally distribute the load to one or multiple machines. That, by the way, is the same thing that my cluster is also doing. The only difference is A cluster has one primary and multiple secondaries, or one writer and multiple readers, or one master and multiple slaves. Call it by whatever name you want. But at the end of the day, one machine is doing the job, or it is telling the other machines what those machines have to do at the end of the day. Apart from that, a cluster manager itself will also perform the activities regarding the databases. It is not like if I have one primary and two secondaries, my primary is not going to do anything. Rather, it will simply distribute the load to the two secondaries. No, the primary will also be doing the job. The secondaries will also be doing the job. The only thing is primary is going to monitor the activities of the two secondary machines also. Listen about this and just keep it in your mind, because the same concept we are going to use in our load balancers also, where we will realize that a load balancer does not do any job itself. Load balancer will simply distribute the job as compared to a cluster manager. Okay, anyways, for now, let's go back to our instances. I have one instance inside 1A, I have one inside 1B, I have one inside 1C. So basically what I'll do now is I'll go inside each of the instances and straight away go and install the web servers inside them. So first thing here, and what I'll do is I'll just break it into multiple screens so that it becomes easy for us. This will become 1A, this will become 1B, and this will become 1C for me. Okay, so let's go inside 1A machine. Similarly, 1B and 1C.
We see only one screen.
Okay, yes, right. Now I believe you should be seeing.
Yeah, now.
Okay, so 1C also here. Okay. And the same command across all of them. First, the update to get the package update. Now, this was a question yesterday, that what are the various distributions of Linux you have worked on? And the answer is RHEL, Ubuntu, SUSE, Amazon Linux 2. What are you confident on, or what have you actually worked on? Generally saying RHEL and Ubuntu is the best answer, because companies actually work more on them. So always say Ubuntu primary and then RHEL. And then next was, what is the package manager? So package manager. So example you have already seen also. This is your package manager. You are getting and installing it via this. So your package manager in this case is this. And what are the other package managers? You have your YUM, which is in case of your RHEL, Amazon Linux, SUSE, and so on. That inside DevOps we are going to do anyways. So I install Apache 2 over here. The only problem is that it will ask me, are you sure you want to install or not? So I just give Y over here. Now I don't want to do the same thing again. So I will just give -Y as a parameter over there, which basically is telling me that don't ask for any permission, straight away go and install it. So my Apache web server should be installed in machine 1, in machine 2, and in machine 3. Now, the important thing is all of these machines have different configurations. If you see, this has 2 CPUs and 1 GB RAM. This one, on the other hand, has 2 CPUs and 2 GB RAM. And this one, on the other hand, again has 2 CPU and 2 GB RAM. But anyways, the command doesn't matter much for us, because the configuration is 2 with 1, 2 with 2, and 2 with 2. And this knowingly we had done it like this, where we had created one machine which was T3A micro, 1 GB RAM, T3A small, 2 GB RAM, and T3A 2 GB RAM again. So if everything is good, I go and open the IP address. I should be seeing 1A. If I open this, I should be seeing server of 1C. If I open this, I should be seeing server of 1B. However, I don't see that as of now. Can any one of you very quickly tell me why not?
Allow the port.
Exactly. Security groups, go and allow the ports. So what I'll do is I'll also allow HTTP traffic on top of it. So this one now should start responding. It does. Similarly for 1B and 1C. So there are various ways to do it. One of them is you could have created a new security group itself, which would have enabled port number 80 or HTTP. And straight away, you could have gone and attached that security group to all of the machines. That was also a way to do that. And next one is once we go inside Lambda, we will go and give tags to all of them, right? Tags. So we'll go inside Lambda, we'll create a function, and that function basically will be going and searching for the instances, those who match specific tags, and they will be going and modifying the security group. But that will come inside a Lambda once we reach there. So anyways, if everything is good, this should respond, and this also should start responding by now, and it does. So I see all the three machines over here, machine 1, machine 2, machine 3. Just like yesterday, it is difficult for me to understand which machine is what, which is in 1A, which is in 1B, which is in 1C. So what I'll do is I'll start naming it just. Okay, so over here I go and just change the name of the file. So this is the file that we have to look at. And here inside title, I'll just go and make it as 1A. That makes it easier for me to understand where it is. But remember, in production, you do not go and do this. All the machines have to show you the same data. Right now, it becomes difficult for you to understand which one is what. So I am putting this as 1A. In production, if you go and put all machines with different versions, that is something known as a rolling update. That is something known as a blue-green deployment. So those are the deployment strategies. But inside EC2, we generally keep all the servers or all the machines with the same data itself. Okay, anyways, let's go for the next one. Here, title, let's go and make it as 1B. And here, let's go and make it as 1C. Okay, so this one is 1A. If I refresh, this becomes 1C. If I refresh, this becomes 1B. And I have all the machines which are present for me, which are inside 1A, which are inside 1C, and which are inside 1B. I believe I did a miss. No, that is fine. This one is 1B, 65. 1A is 13. 1A is 13. You can look from here also. You can look from the DNS also. 1B is 65, 1, and 1B is 65, 1, which means 1C is the correct answer also. 3110 and 60.18. Okay, a strange question which was asked for one of the companies was that they are asking some random questions now. The HR had asked that there are 3 bulbs in the room basically, and there are 3 switches outside the room. I can only enter the room once, and I can turn on or turn off as many lights or as many switches as I want from outside. But once I go inside the room once, I have to figure out which bulb is 1, which is 2, and which is 3. Think about the answer. This is a general GK question. This was asked in the HR round of the biggest telecom company in the world. Okay, so 3 bulbs are there, 3 switches are there. You can enter only once, and you can switch on and switch off as many times. But once you enter the room, you have to figure out which bulb is what. That's it. So think about the answer. Maybe it is asked to you also. Okay, anyways, I have 3 servers. I have 1A, 1B, and 1C. Now the strategy that I have to do is that if any of the machines go down, my service should not go down. Consider this like a simple cluster wherein I have 3 machines. If one of the machine goes down, my cluster endpoint or my cluster should not go down at the end of the day. For this, what should I do? The answer is you can use the concept of a ELB or a elastic load balancer. Why elastic? Because load balancer settings you don't have to worry about. You don't have to worry and think that if my load balancer itself goes down, or if my load balancer is unable to handle the traffic, what do I do? That you don't have to worry. AWS is automatically maintaining the load balancers. AWS is automatically ensuring that your load balancer service in itself does not go down. And why it is elastic? Because the same thing, why is it elastic compute cloud? Why is it elastic block store? Why is it elastic network interface or ENI? Similar concept. Why is it elastic load balancers or ELBs? Now, generally, the mistake that people do is whenever you listen about the word ELB or elastic load balancer, you generally start to think that they only mean this load balancer, network load balancer. This is wrong. Whenever I talk about a load balancer or an elastic load balancer, it can mean either ALB or application load balancer. It can mean NLB or network load balancer. It can mean GLB or gateway load balancer. It can also mean CLB or classic load balancer. If you are a fresher, I can guarantee you, or even if you have anything less than 4 years of experience, which means you are a fresher in AWS, in that case, they will ask you what are the type of load balancers. And your answer is ALB, NLB, GLB, and CLB. And after that, say that CLB will retire on August 15, 2022. If you are from India, it is not difficult for you to mug up this date, August 15th. So this year on Independence Day, CLB or the classic load balancer is going to retire. So whosoever was working on CLBs will cease to exist, and we will anyhow see that how we could have easily migrated our application from CLB to ALB. So we will talk about that. But before I go there, what I wanted to tell you was that whenever you hear about ELB or elastic load balancer or simply load balancer, it does not mean this, but ELB in general means ALB, CLB, GLB, or NLB. And CLBs or the classic load balancers are going to expire or retire on August 15, 2022. Those who have done EC2, I did tell you something as capacity reservation. So now you might understand what is the advantage of a capacity reservation. When something retires and you still want to keep it, you know the service that you have to use. This, however, cannot be applied to load balancers because capacity reservation is for instance. Load balancer is not an instance. Load balancer is a service by AWS. So that thing you don't have an option. You will have to migrate from CLBs to ALBs or NLBs or whatever load balancer there are. Also, the migration wizard of CLB to ALBs are already present. Also, if you were working in AWS, you would anyhow by now have migrated from CLB to ALB, and the primary reason is money. CLBs are 30% more expensive as compared to ALBs or NLBs. So anyhow, you would have realized if you were working or if your company is working on AWS, some smart person would have realized that CLBs are expensive, and by that logic, they would have anyhow migrated them to different load balancers. So I am almost sure that your company, you are never going to see CLBs or classic load balancer. But if your experience is more, or if you are showing that your experience is more in AWS, please unnecessarily use the word classic load balancer. That will tell the interviewer that indeed you have been working in AWS since the time your classic load balancers were in existence. Now, enough said. What is a load balancer first of all? A load balancer, very simply put, is a machine that is going to distribute the load to multiple machines. So what happens is whenever you hit any endpoint or any IP address on the internet, go back to class of Route 53 where you were hitting the C name or the A name or the MX name. It was being forwarded to a specific IP address. That IP address, by the way, could have also been a load balancer. Now go back to your class of Route 53, where when I was creating the endpoints, or rather, let me show it to you very quickly. And then we'll resume from there. So assuming that I'm inside Route 53, and needless to say, ELBs are a region specific thing, and the reason is it is inside EC2, and EC2 are a region specific service. So if I go to Route 53 pretty fast and I go to traffic management and I give a name, connect, let's say a geolocation, and let's put it as Asia, and here let's put it as some proximity. And then if I had given a new endpoint, at that point of time, I told you value, you understood, IP address, S3 website, you understood the website, CloudFront distribution, you understood. Then these three things I didn't tell you. And I told you by the time we do load balancers, you will understand. So if in case I have a application load balancer or a ALB or a CLB or a NLB, if at all I had them, it would have been available in the drop down over here. Which means if someone in Asia is within this latitude and longitude over here, in that case, they will be forwarded to this specific load balancer. Next up, what is a load balancer? So we do know that by now, if you are opening up your website via the dig command, somehow you understand that I have to navigate to this NS or the namespace servers, and that NS based on the A record or the CNAME, based on the routing policies, would have forwarded you to either CloudFront or S3 or IP or the load balancer. So here we are now. This part is already done earlier. If I am inside the load balancer, I have options of these four machines. My load balancer now has to decide that the traffic should be routed to which of the instance. Remember, it cannot be routed to all of the instances. That is where inside our VPC, we had the concept of traffic mirroring. The same data which went over here also went over here. Load balancer, on the other hand, will simply send the data to any one of the machines. There is no preference which can be set that this data should go to which of the machines. However, logically, you might understand that the data will be going to which machine. How? Let's consider this statement. A load balancer at the end of the day, consider it like your manager, and these are the four developers, developer 1, 2, 3, and 4. So now a task has been given to the manager, or rather, let's say four tasks have been given to the manager. The manager will start distributing initially in a round robin way: one, second, third, and fourth. Next, another 10 tasks will come: 1, 2, 3, 4, 5, 6, 7, 8. By the way, there is a logic to this story. Whatever I am telling you, remember, I am saying cyclic, which means I will also have to prove it to you technically that cyclic order is followed, and I will prove it to you. But for now, just trust me when I say that in a round robin way, the data will be sent to machine 1, 2, 3, 4, 5, 6, 7, 8. Two messages are left. Ideally, it should be sent again 9 and 10. This is what a load balancer should be simply doing. Next statement. What if a developer can do, this developer did the job in 30 minutes, this developer is doing the job in 4 hours? Obviously, you understand, if you are better at something, you will be given more work. In that case, it will be given in this way: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, until this developer can do the job, because I know they will be taking approximately 3 to 4 hours to do the same task. Which means that logically my load balancer would have automatically decided that I have to route the traffic to which preferred instance. And that again, I start my AWS class talking about latencies. Latencies are applicable here also. My load balancer is sending a request to the end server. The end server is responding back within 10 milliseconds. This is taking 80 milliseconds. This is 8 times faster than this. So eight messages will be sent over here, and one request or one message will be sent over here. That is how the load balancer is actually distributing the load. First thing. Second thing is this, assuming that this machine is not responding only. In that case, a load balancer will be sending the data to 1, 2, 3, 4, 5, 6, 7, 8, 9. But the important concept here is how will the load balancer even know if this machine is active or not? In this case, what happens is a load balancer itself will start to send the messages to each of the machine. This thing is known as a basic health check. What actually happens is I send a request to each of the end machines or the target machines, and the target machines have to reply back within some specific time. Easy way to understand is I say, "Hi Sam, how are you?" And Sam replies back after 5 years saying, "Hi Ankit, I am good. How are you?" Doesn't make any sense, right? Similarly, over here also, if a load balancer is sending a message to the server has to respond back within 5 seconds or 10 seconds or 15 seconds. If it does not respond back, in that case, it is not like I'll stop sending the messages. After 30 seconds, I will again send you the message. If you still don't respond back, 2 consecutive times you have not responded back. In that case, I will remove you from the load balancer. I know you are unhealthy instance. The keyword is unhealthy instance. On the contrary, I sent a message to 2, responded back, sent a message to 2, responded back, sent a message to 2, responded back. So if you respond back to me 3 times or 4 times or 10 times, depending on how much threshold I have set, let's say I have set threshold as 10. It means if I send a message to you, respond back, message, respond, message, respond. If this activity continues 10 times, in that case, this machine will be deemed to be an active machine. So in this case, this is a live instance, this is an active instance, this is a healthy instance. In various cloud providers, you have various words to describe this. Algorithm remains the same. How you describe the instance only differs from one cloud provider to the next one. So in that case, if this machine sends back the response 10 times or 2 times, I will deem that you are active and I will start to send the message to you. Similar thing applies with this, similar thing applies with this. But just because you replied back to me 10 times does not mean I will again not ping you. I will again ping you after 30 seconds and you again have to respond back. I will again ping you after 30 seconds. You again have to respond back. In that case, your load balancer will automatically know which of the instances is healthy, which of the instances is not healthy. The beauty about this thing is you don't have to manage any of this. This is automatically done via AWS themselves. Your simple job is to create a load balancer, describe the end instances, and a load balancer will automatically route the traffic to then any one of them or in a cyclic method. The concepts here were healthy threshold, reply back to me 10 times, you are active or healthy. Unhealthy threshold, don't reply back to me 2 times. I will stop sending you, but again, I will send you after 30 seconds. If you again don't respond back, no worries, you were anyhow removed. But if at all you respond back 4 times, I will wait for 10 more times. 5th time, 6th time, 7th time, 14 times or 4 to 14th. In these 10 iterations, you have to respond back with success. If you do, you are added to the load balancer. If you don't, you again have to send me 10 healthy thresholds or 10 healthy transactions to prove that indeed you are an active machine. So in this case, this is what a load balancer works, and this is what is known as the basic health check. No one will honestly ask you about this health check Only if you are going at the architect level or at the senior architect level, these things they are going to ask you. The beauty of what means theoretically they will ask you because you don't manage any of this. You can only decide what is 5 seconds, or you have to respond back to me within 5 seconds, or else you are unhealthy. You can only change that. You will have to come back to me. I'll come back to you after 30 seconds. That you can change. Third, if you don't send me the request 2 times, you are unhealthy. You can make it 2, you can make it 10, whatever you want, 2, 3, 4, 5, 6. Similarly, healthy, if you respond back to me 10 times, you are healthy, or if you respond back to me 5 times, you are healthy. This configuration only you can change. Rest, anything AWS doesn't give you the access only. On the contrary, if at all you were inside Azure, you had one other option wherein you could have decided that which preferred server you have to go to. That concept is known as stickiness. The same thing we are going to see inside AWS also. It is not present, but it is, you can actually see it live in action. Now, enough of stories. Let's get started with load balancer and prove the stories, whatever I told you. Are they actually live in AWS or they were stories? Let's get started. We already have 3 machines, by the way, pre-request 1A, 1B, 1C. Next up, I go and create a load balancer. We will start with the classic load balancer, CLB, which is anyhow retiring. So in this case, I just have to go and give it the name. Let's call it as CLB itself. Now, you will be hitting load balancer on a specific port. Load balancer itself will be forwarding you to a specific port. What does it mean? This where you are pointing is your load balancer port and protocol. And load balancers internally are hitting the instances. No, this is your instance port and protocol. That's it. So this part is more about route 53. This part is more about your EC2 instances. Next up, okay, you can create an internal load balancer, which means it is not having a public IP, and you can have the advanced VPC configuration, which simply means which all subnets you want to add it. So any point of time, even if you add it or you remove it, you can always go and modify it. So it doesn't make any sense. Alternatively, if you are working on load balancer, you would have automatically thought about high availabilities like we have done. If high availability, HA or high availability, anyhow, all the instances would be present in all of the subnets. If that is also there, so it doesn't make any sense, but yeah, you should know what it actually means. That's it. Okay, anyways, security group, because just like my EC2 instance, my load balancer also has a security group. Keep this in mind. Same thing we will see in ALBs also, and the same thing we will not see in NLP. Okay, so I have created a security group already, which simply has port number 80 enabled. Don't want it, you can always go and create it yourself also. So, or rather, let's create a new one only. Fine. I want my HTTP traffic to go from anywhere. Next, if you have any security groups available, or if you have any security setting or TLS settings available, you can do that, which basically means if I had my TLS protocol or SSL protocol, in that case, I would be having my certificate from ACM. ACM again, we have done inside our Route 53, inside our Cloud Front. So I won't again bug you on that, how to create ACMs. But this is what it is. Means if you want it to work on 443 also, you simply have to go over here and you have to go and give SSL traffic also. If you do this, in the next step, you will get certificate option. If you do not do this, in that case, this option will come as blank over here. For me, I don't want, I just want it on 80, so I'm just leaving it as it is. Next up, this thing, you already know the story. I will, load balancer will hit you and expect a file as index.html. Load balancer expects the response in 5 seconds. It will again ping you after each 30 seconds. If you don't respond back 2 times, you are unhealthy. If you respond back 2 times or 3 times or 4 times or 10 times, you are known as a healthy instance. What I'll do, I'll decrease this, or fine, let it be 10 only. Next up, add the instances to the load balancer. You just have to go and select this. Anyhow, you could have selected or deselected later also, that I am going to show you. Next up, add the tags. I'm putting as CLB and I'm putting it as type is classic and region is Mumbai and created by here, and service name is backend video. Okay, so these are the tags that I have added. Next up, create, and finally go and create it. Now, if everything is good and whatever things I told you are true, in that case, you have the DNS name. By the way, if you have the DNS name, this also means that this Route 53 routing rules, you could have added this DNS there also. And if everything is true, if I just go and hit this over here, I should be seeing 1A or 1B or 1C. Rather, it tells me that none of the things are available. So if I go over here, I don't see anything coming up. And the reason for that is, any one of you very quickly, why? The answer is in front of you only actually. Fine, it says 0 of 3 instances in service. In short, it is simply telling you that none of these agents over here or none of the instances over here are responding. Why? Basic health check, by the way. That was the reason. So if you remember, I sent a request to you. You have to respond back to me. I again send a request to you. You again have to respond back. You have to do it 10 times. The basic health check was happening at that point of time. Now that it has happened, if you go over here and go over here, you should see something coming up. Is it coming as? Can just any one of you go and ping this address? Here it comes up. I don't know, maybe some issue with my browser basically. So happens a lot, but anyways, let's go here and open this. I see 1C over here, right? If I refresh it, I see 1B. If I refresh it, I see 1C. 1A, 1B, 1C. 1A, 1B, 1C. Have a look at this title bar over here. So what do I see? 1A, 1B, 1C. Which means whatever stories I told you, that it is doing a cyclic routing from 1A, then 1B or 1C. Now, basically, it is not like it will be 1A, 1B, 1C only. It could have been 1B, 1C, 1A. But what I can guarantee you is cyclic is going to happen. First 1B will happen, then 1C will happen, then 1A will happen. Or if 1B, 1A, 1C is happening, that cycle is going to continue. That can be guaranteed. So if any one of you anyhow has opened up the browser, and if you hit this address at the end of the day and you keep on refreshing the page, you will start to see the same thing, 1A, 1B, 1C, and this basically keeps on moving as it is. Okay, so that is the concept behind my classic load balancer. All the instances are healthy. Next up, next type of load balancer, application load balancer, pretty straightforward. Just go and give it a name, same old story. Internet or internal, do you want IPv4 or IPv6? I want IPv4 only as of now. What all subnets you want to enable? I want to enable all 1A, 1B, 1C. If I have any security group, I could have given that. If I don't have, that is fine. Next up, I will have to go and forward it to a specific set of instances. The important thing here is a classic load balancer had instances directly attached to them. Application load balancer and network load balancer and gateway load balancer do not directly add the instances to the load balancer. Rather, they are attached to something known as a target group. And the target group in itself are going to go and forward the traffic to a specific load balancer. That is how it is. Now, one important question is, can I go and add multiple target groups? And the answer is in front of you. Yes, but the port number should be different. Why? Classic thing on a single port anyhow, one service or one application or one endpoint or one PID, how we call it in Unix, can only exist. For that reason, on one port, only one target group can exist. However, I can attach multiple target groups to the load balancers provided they are forwarding to a specific target group. So in this case, because I don't have any TG or target group as of now, I will click on create target group. I will add the instances. Pay attention. My application load balancer can forward to IP, Lambda, or even other ALBs also. Keep it in mind, NLB won't be having 4 options. So I won't repeat myself over there. Just remember it had instances, IP address also, Lambda also, and ALB also. So instances over here, and I'm calling it as ALB hyphen or target group hyphen application load balancer, which is inside my VPC. Next, if you want to add any healthy threshold, unhealthy threshold, you can give that also. Next step, same old story. You just have to go and add the instances over here and create the target group. And once the target group is there, it is telling you I am not associated with anything. And indeed it is not, because I need to go here and select my TG. TG not available because refresh. Where are you? Hold on. Just a minute. Let's refresh the page. So let's first see the target group. Why is it not coming up? Okay, that's fine. If this happens, basically, it's never happened with me, at least as of now. But if it generally happens, no worries. Delete and hot reload the page. Basically, Control R on Windows or Command R on Mac. So let's go and do the same thing here. Cancel this and refresh the page. It is somehow behaving in a strange way today. Or maybe because it is new, easy to experience. Let's just reload it and try again. Fine. Load balancer, application load balancer. Let's call it as ALB. And this has to be in 1A, 1B, and 1C. Next, security settings. I don't have any TLS as of now. Next, I am using my existing security group. Next, routing. I am creating my own target group, which I am calling it as target group hyphen application load balancer or ALB, which is anyhow working on an instance. Next, add the targets straight away over here. Next, review and create. If everything is good, your application load balancer should also show up, and over here and over here. If you hit this again, it should give you something. It should give you right now. It is not, because this for some reason is forwarding me to this link over here. But in either case, if I go and open it in my incognito window, it should go and show me either 1A or 1B or 1C. And the reason for that is, okay, right now it will take time. Again, the same old story. It will take some time in provisioning. And while it is taking time in provisioning, it will take 3 seconds or 30 seconds into 3 iterations, at least 90 seconds. And my healthy threshold was set to 10. So in 5 minutes approximately, my load balancer should be in active state, not into provisioning. Meanwhile, while it is happening, actually, let's go and also work on the NLBs or the network load balancers. Network load balancer. Okay, very quickly have a look over here at ALB. ALB only had HTTP and HTTPS. Keep it in mind. Only HTTP and HTTPS. Okay. On the other hand, if at all I want TLS or TCP or UDP. Now, you might argue that HTTP is also TCP, and that is indeed the correct statement. Yes, it is. But there are other scenarios in which you might need specifically TCP connections only. So what I mean is something like the biometric devices, which are directly interacting with your servers. In that case, it is interacting over your TCP endpoints. In that case, it will go and work on your network load balancer. So here, and network load balancer, in this case, let's give it as NLB, again, the same old story, internet facing IPv4 or dual stack or IPv6, which in turn is working on port number 80. And I want to go and enable 1A, 1B, 1C. Now this it says is temporary limitation. This temporary limitation has been there since 2018, which means once you assign, you cannot remove it, remember. But if you haven't added, you can add it later, that is fine. But the moment you add it, you cannot go and remove this particular AZ from this load balancer. Neither a support ticket works nor anything. Next, security I don't have because I don't have TLS. Next, let's create a target group. Let's call it as TG-LLB, which is working on an instance. Go back to your application load balancer. You also had Lambda over here. So a difference there, HTTP, here TCP, there instance IP and Lambda, here only instance and IP. Next, okay, you can also have the health checks by the way, but I'm using the default one. Next is your targets. Go and add them here. This, next review, and finally create. If everything is done, your network load balancer should also be active in some time. Meanwhile, let's go to our ALB or application load balancer and hit the address over here. And I should see 1B refresh, 1C refresh, 1A, 1B, 1C refresh, 1A, 1B, 1C. Have a look over here on the title bar of the web page, 1A, 1B, 1C, 1A, 1B, 1C. This is also indeed routing the traffic to my specific instances or to specific endpoints, either 1A or 1B or 1C. Same thing is going to happen with my NLP also, or rather a different thing is going to happen over here, which is known as your stickiness. Now, by the way, it wasn't working for me earlier. It is working for me now. The reason for that is, generally speaking, if you are working on the console, that is also a reason why we prefer not working on the console. This toggle new EC2 experience and old EC2 experience, generally sometimes things don't work on your new EC2 experience. That from experience I can tell you. In that case, it's pretty easy. Just straight away toggle this back and reload it multiple times. Again, Control R on Windows, Command R on MacBooks. That can be done. In that case, it will automatically reload it and then it should work. The same thing which was not working earlier is working now. Fine. So this is my load balancer. By the way, if load balancer is all good, we'll just wait for it to provision. There is something known as a sticky session inside your general concepts of load balancers itself. And the concept here is that if my instance if my load balancer has to forward my data to a specific instance, in that case, do I forward you to 1A or 1B or 1C? I have already decided. Now, if I have decided you go to 1A, next time again, if I get the request, which means if I refresh the page, or I am sending the same request to you again I have to decide, do I send you to 1A and 1B and 1C? The concept of load balancer is that load balancers are good and you don't have to worry about whether they can handle the traffic or not. They will handle the traffic. There's no question in that. But why should my machine each and every time decide that whether I should go to 1A or 1B or 1C? If you have already, or if I have already sent you to 1A, if I decided that this IP address or this request has to go to 1A, if I get another request again from 1A, or if I get the same request again from the same IP address, I will again forward you to 1A itself. So why should I even think that whether I should send you to 1A or 1B or 1C if I have already made the decision that first time you came to me, I was forwarding you to 1A. This thing is known as a sticky session. Sticky session by the word itself is telling you, because I already decided you have to go to 1A, in that case, you should automatically go to 1A only next time. This thing is known as a sticky session. This is not present in ALBs or CLBs. This is by default enabled on your NLBs or network load balancers. Let me give you a proof of that. See if I have an incognito window still opened up. No, fine. So this one is NLB, by the way. How do you know? This is network load balancer over here. Okay. NLB. And the same thing, let's also go and take a ALB here. And let's also take a CLB, though it is retiring, but still, let's go and take a CLB also. In some of the interviews, they will ask you about a sticky session. So see it live in action. If I refresh the page, you see this title is going to change. I am talking about the CLBs right now. Okay. 1A, 1B, 1C, it is changing, right? Because stickiness is not enabled. So each time it is forwarding you to a different machine. ALB, same concept. If I refresh, I will see 1A, 1B, 1C going on. Okay. Same thing, NLB. This is not going to happen. I am refreshing the same page, but I am being forwarded to 1C only. This thing is known as stickiness. This thing is known as a sticky session. By the way, what does it not mean? It does not mean that if I have sent you to 1C, forever I will only send you to 1C. No, sticky session have some values, 30 seconds, 60 seconds, 90 seconds, which means if I have sent you to 1C and you again send me a request within 30 seconds, I will again send you to 1C. But however, if you are sending me the request at 31st second, I can send you to 1A or 1B or 1C. Maybe again I send you to 1C. Then again after 30 seconds you ping me. In this case, I might send you to 1C or 1A. If I am sending you to 1A, this has changed. Now, if you ping me within 30 seconds, I will be sending you to 1A. If you don't ping me, I will sending you to 1C. But in reality, if you see, it doesn't matter because from your perspective, all the instances are the same, right? That is the concept. All instances have to be the same only. So if they have to be the same from your perspective, everything will look the same only. So this is what it means. Anyways, if I go to my NLB and I refresh it again, you see I am still being forwarded to 1C itself. This one, on the other hand, is sending you to 1A, 1B, 1C. This thing, on the other hand, is sending you to 1A, 1B, 1C. By the way, I also told you one thing in the beginning, that if my instance goes down, my load balancer should automatically, let's say 1A has gone down. So my load balancer should now send the traffic to 1B and 1C, right? Proof of that. Let's go to instance and stop my 1A instance. Okay, those of you who are working on the new console, this is a bit different actually. This will come inside instance state. In the new console, it has been replaced. It is coming inside instance state itself. On the old one, it was inside your actions and instance state. Because AWS realized that people use this thing a lot, instance state. Okay, so now what is happening is instance will not stop straight away because there is something known as a draining connection. Draining connection means that if at all my load balancer is, let's say my instance 1A has stopped, or 1A I am stopping, or it has stopped, AWS will try that whatever connections or requests were sent to 1A, I should have received the response of it from 1A itself before the instance has stopped. This, by the way, is known as a draining connection. There is also something known as a delayed start. Delayed start means that the moment I start a machine, it doesn't mean that AWS will straight away start and add the instance to the load balancer. No, AWS will generally wait for some time so that the instance can actually, the term is warm up. So that the instance can do a warm up, which basically means, let's consider it like this. You started your laptop today. It doesn't mean at that very moment itself, every service will start working. It has to process some activities and then the other applications have to start that thing. But you say, no, I want it to start immediately. In that case, inside DevOps, we are going to see the priority of the services or the applications which have to run. There we can set the priorities of the applications also. In that case, they will be booted up in that order. Okay, anyways, 1A has stopped, which means if I go to my load balancers now over here, I shouldn't be seeing 1A over here, right? Refresh, you see 1B, 1C, 1B, 1C. You don't see 1A itself. Same go to your classic load balancer. You only see machine 1B and you see machine 1C. Go back to your NLB, which anyhow earlier was forwarding to 1C. Stickiness session disabled. Now it is forwarding you to 1A itself, which means for next few seconds or whatever interval is there, it is going to forward you to 1B instance only. By the way, last part, what if my instance comes up? So in this case, what you would have done is you would have created an alarm over here that if my instance at any point of time goes or stops, in that case, send me an alarm. More about it inside our CloudWatch. More about it inside our events bridge, by the way. If instance stops, go and send me an email, make it even smarter. The moment your instance stops, send me an email, also call a lambda function. Lambda function will automatically go and start the instance. So in that case, you don't have to go and manually start it. Lambda would have done it automatically. That thing is known as infrastructure as a code or serverless architecture. Basically, you only get notifications, instance is stopped, instance automatically recovered, instance automatically started. But that will come once we go inside our Lambda. So in any ways, this means that if I go to my load balancers now and I go to my CLB, it says 2 of 3 instances in service because third instance would be coming up. Why? It has failed the number of unhealthy checks. So remember, 1A went down. 1A went down means 2 times it didn't respond back. If 2 times it didn't respond back, it simply means that my load balancer or whatever load balancer is there, removed it from that load balancer. Done. That is the concept of my ALBs. Anyways, so CLB now has 1A, 1B, 1C. This one itself has the target group, which is this, which would be saying that one instance is unhealthy as of now. So hold on, this instance will come up shortly, which means that if I go to my ALB, I am going to see 1A, 1B, 1C. If I go back to my CLB, I will say 1A, 1B, 1C again. That, by the way, is the proof that if 1A goes down, it is removed. And if 1A comes up, it is again added automatically. You didn't apply any logic on that. Load balancer automatically understood all those things. Network load balancer, on the other hand, is still working on stickiness, which simply means that I am still forwarding you to 1B instance itself. This is the concept behind your load balancers or your ALBs and NLBs and CLBs. Now, over here, you see, this instance is still saying unhealthy. So ideally, if it is unhealthy, why is my application load balancer forwarding it over here, or why is my network load balancer by that logic forwarding it over here? This thing is known as a passive. I don't know if AWS has a document also of it. This is known as a passive health check in load balancer. Okay, so again, this is done by AWS themselves over here, this one. So, okay, they have something, means it's very hard to find this documentation, but this is what AWS does itself. You don't have to manage that. It's like you have given your health check of 10 unhealthy instances over 30 seconds. So if the machine doesn't respond back 10 times over 30 seconds, which is 10 multiplied by 30, which is 300 seconds, which is 5 minutes, or technically speaking, it actually starts at 0th second, not at 30 second, in which case it is 30 into 90, 270 seconds or 4.5 minutes. So only after 4.5 minutes, your load balancer will realize that this machine is not active. Now, again, if you did not understand this, that is perfectly fine. AWS wants you not to understand this. That is why AWS calls it as a passive health check. Active health check is what you create. Passive health check is AWS says, you don't worry, whatever health check you give, it is fine. I do a health check myself internally. That AWS is not telling you, by the way. That is why in that health check, it was saying it as inactive, whereas your health check was calling it as active. It can reverse the roles also. Your health check might say it is active and AWS might say it is inactive. In that case, AWS will automatically remove the instance from the load balancer itself. That is known as a passive health check. Again, done by AWS. Again, you don't control it. Again, the advantage is you don't have to apply your logic or brain into that. AWS automatically knows what has to be done. It will automatically add the instance or it will remove the instance. That's it. This, you see, is the concept behind your load balancer. By the way, if you have understood till here, uh, we can go for network interface, or rather, I think I should be telling you this in your normal weekday class only. But just remember it, CLB had 1, 2, 3 IP addresses. Okay. ALB had 1, 2, 3 IP addresses. NLB has 1, 2, 3 IP address. And now see, NLB had 1B, NLB had 1A, NLB had 1C, which means it is across all the three AZs. And why all the three AZs? Because while creating your AWS VPC, you had three AZs which you had selected, or three subnets which you had selected. So each of the subnet, by the way, has its own IP address also, which is over here, which means what is this NLB? Let me go for ALB actually. This IP address, you could have also forwarded it to IP address, by the way. But the only problem is this, you forward it, it will go to 1A, 1B, 1C, which is your application load balancer, which means it can forward to this also. And next ALB is this, right? This IP address. It can forward you to this also, which is again the same thing, 1A, 1B, 1C. And 1A is here also, which means ALB can forward you here also. And this, by the way, are all the three IP addresses of ALB itself. That's the beauty of ALB. So if you are forwarding to an endpoint, actually, no, when you say that I am forwarding the data to my load balancer and my load balancer is forwarding to this DNS name, what actually is happening in the background? This you could have very easily realized by doing a ping. So where is it actually going? 35.154.196.206. Remember 35.154, which means it is actually going to 35.154.196.206, which means the primary network interface which it is choosing is your ALB, and inside ALB it is going inside 1A. So what AWS dig is doing, or DNS is doing, first of all, it is forwarding to this IP. Assuming this network interface fails, next it will pick up any one of them, and next it will pick up any one of them. This is how it internally works. This is important because along with the public IP, I also have a private IP. So if I wanted to create my load balancer as an internal load balancer, no logic, just point it to any of these private IPs. By the way, VPC CIDR blocks, you already know. That is why my VPC default is 172.31.0.0/16. That is why this obviously has to be in the range of 172.31 or whatever that address is. So this is how complex it is. But from your version, no, you don't have to worry only. From your logic, you simply go create 3 instances, go to load balancer, create a load balancer, add the instances to the load balancer, and that is pretty much it. But just appreciate that behind the hood, a lot of things are happening. AWS load balancer itself having whatever subnet groups you have given, those subnet groups themselves having their own IP address. Those IP address are nothing but your network interface. And this IP address again is a public and a private IP address, and that internally is forwarding to 1A, 1B, 1C, because at the end of the day, it is a load balancer only. So this is the concept behind your load balancer. By the way, there was one more load balancer also, which was a gateway load balancer, but just tell this in the interviews. The reason for that is this is used by third-party appliances. So inside AWS, it is almost impossible to use it, but still, if you want to use it, if you, let's say I don't have any instances, neither HTTP or HTTPS, neither TCP or UDP. Classic load balancer, by the way, was for everything. That was the beauty of classic load balancer. It could have been TCP also, SSL also, HTTP, HTTPS also. ALB is only for application traffic. NLB is for TCP, UDP, basically anything, which means it can also work as an application load balancer. By that logic, ALB can work as a network load balancer if you are working on TCP on port 80 or 443. If you understand it, good. If not, one more thing, NLP can also support endpoints over here, which is not supported by application load balancer. NLP has stickiness. Stickiness means I don't have to apply my brain where I have to forward you, which means I don't have to go and do some calculations, which will mean that latencies will be low, which will means I can do more transaction, which basically means NLPs are capable of handling million of requests per second, maintaining ultra low latencies. This is what it means. Ultra low latency, because stickiness inherently is created inside your NLPs or network load balancers. Next up, gateway load balancer. If you want using Genevieve protocol, you can click on create. The concept remains the same. The only thing is you don't have IPv6 over here because Genevieve anyway doesn't support that. The rest all things remain the same. Again, create a target group over here. And the target group you can go and attach to whatever instances are working on that protocol. Or else go to your load balancer here, and with the old one also you can go and create. Let's call it as GLB and 1A, 1B, 1C. Now this one I honestly can't show you because I don't have only any instance with Genevieve protocol, obviously. So, but if I still wanted to at least create for you target group hyphen Genevieve, which is working on port 6081, which will be on TCP itself. Next, add whatever instances are there, provided they were on that protocol, you can have gone and create. The only problem is that nothing is going to work over here. And just remember that this has to be done in route table, internet gateway or transit gateway. This thing already done in VPC, so I won't bug you much into that. This is the concept of your GLBs. Will not come up actually. Even if it comes up, it won't give you any response only because this is interacted via your ARNs and not via these endpoints. This is not a web server or application server. That is why. So this one is the concept behind your load balancers. Any questions if you have? No. I do understand it would have been pretty much for you to digest at the moment, but just have a look at it. You will understand it better. Any questions if you have?
How to choose which load balancer we should use, like network or application?
I'll say NLP. I use NLP. NLP's latencies are low actually. That's why.
Oh.
Okay, and NLP, if tomorrow you have concept of UDP traffic, no, see TCP on 80 is NLP, TCP on 80 is ALB. At the end of the day, HTTP is nothing but TCP only. So that is on port number 80. So you can use any one of them. But tomorrow, let's say you have a specific requirement of using UDP traffic. In that case, what do you do? In my case, I have this problem. We are working on IoT devices. They are all working on UDP only. We are working on blockchains. They are all working on UDP only. Means blockchains generally work on UDP. There is no hard and fast rule, but they generally work on UDP. In that case, if I have to create a load balancer, in that scenario, I have to use this. Now, one more example I can give you, a real-time example if you want to use it. In our case, we were working on the biometric machines, the fingerprint biometric machines, and we had to create an application for a client which was doing the biometric attendance, basically salary calculations and all those things. So the moment you swipe your finger and you swipe it out, we do the calculation, and based off that, we calculate the time and how much salary should be given. The thing is, biometric device is sending the request to an end server. Now, in our case, this end server was not a local machine because local machines can be modified. So rather it was sending it to a endpoint machine. That machine was a hosted machine which we created it. So initially we took the software from that vendor itself and we were provisioning it on the Windows machine. Now, Windows machine, we had to install our Visual Studio. We had to run that, and those machines were sending the request to the Windows server. Problem here. If a biometric machine, first machine we installed, everything was working. Second machine we installed, everything was working. Third machine we installed, third machine is not working. It took almost a day for us to realize why this thing is not happening. The thing was, third machine we started with me. It was a different office altogether. So initially we were wondering if networking is wrong or unable to reach the address, all those things over there. And at the end of the day, these machines are working on UDP. So there is no way to get an acknowledgement back. So you just have to go and check out the network packets one by one. And network packets over the internet or over cloud or over AWS is extremely difficult to traverse. So we use various things over there. Then we realized that, okay, do a thing, switch off machine 1, switched it off, machine 3 started to work. Then we switched off machine 3. Okay, now we switched on machine 1. Now machine 2 and 3 were working. Now machine 1 is unable to connect, which means that at a point only 2 machines were able to connect with my Windows server. First, we thought this is the problem with the software or the application which is running. We contacted them and they said it is not a problem with the machine. After some digging, we realized that you can only create 2 connection on Microsoft Visual Studio, or any VB applications can only create 2 simultaneous connection. If any one of you over here is working on VB, maybe you can confirm that, or you can even tell me a smarter way to do it. So as far as we realized, the code in VB.NET was only supporting 2 machines at max. Now, how do we solve this problem? Easiest and the dumbest solution possible is you create one Windows machine, you create another Windows machine. Next 2 machines are pointing there. You create another Windows machine. Next 2 machines are pointing there. That would have increased the budget. So what I did over there was, remember what a load balancer does basically. What does it do? It takes the request from multiple and via one load balancer, it is sending to this machine, right? Now, these 3 machines are not there. I know my Windows can only accept 2 requests at max, right? I said, don't accept 2 requests, handle only 1 request, but you will handle the request from the load balancer. So what happens is all the 400 machines now as of today are sending the request to the load balancer directly. And load balancer is sending the request to Windows machine. Remember, Windows machine can only handle 1 request. And Windows machine is still handling only 1 request, right? Because it is only getting it from the load balancer. These 50 people are sending request to load balancer, and load balancer one by one is sending the request only to one server over here. Now, you can create multiple servers over there also, not a problem. But in my case, we didn't have the budget and we wanted all these things to be done by one machine only. So this one machine is only getting the request from one load balancer, and all the different machines are sending the request to the load balancers here. This is the solution that we deployed over there. If you want to use this in your requirement where people say that, what did you create in NLBs, or tell me a real-time scenarios of your NLBs, feel free to use this. And you can say just that we had the biometric machine and this is the thing that we did over there. Now, anyhow, the code that was in VB, we have changed it to a Node.js code. And now these machines are directly pointing to the elastic IP of that single one server that is anyhow working in our kubelet basically. So Kubernetes, and on the Fargate pods it is working. So now anyhow it is happening via that. But back in 2018, this was the solution that we deployed, and this is a real-time solution what you can probably use for NLPs. NLPs, remember, if these machines from 400 tomorrow increase to 4,000 or 40,000, it would still not be a problem for me. NLPs can handle that much traffic. 40,000 is too less. NLP can even actually handle millions of transactions per second. So this one, if you want, you can use it. Fine. Any questions if you have now?
No, in that example, so load balancer will queue the request from all
No,
those
load
machines?
balancer is simply sending the request one by one. No, so even if load balancer sends 100 requests per second, it is accepting only from one endpoint. No, load balancer is one endpoint only. No,
correct. Okay.
Right. So that way it worked. Okay, just because you understand what a load balancer is, this is there.
Is there any concept in the load balancer? In the load balancer?
Concept as in?
Load balancer. Do you have any? You can add any more load balancers?
You can add as many. You can add as many load balancer. Yes.
In load balance itself, do you have any backup like that?
No. Okay, load balancer anyhow is not doing any data provisioning. No, it is simply routing the traffic. That's why. Why do you even need that?
Yes. How many requests it will?
No, I'll tell you. Your question is pretty valid. I'll tell you why. Your
Yes.
question is valid because what Ravi means is, Ravi says that, okay, tell me this thing, your biometric machines were sending the request to the load balancer. I very well understand you cannot send it to a load balancer, rather you will be sending it to a IP address, right, Ravi?
Yes,
So
yes.
if you are sending it to the IP address and tomorrow if that load balancer is destroyed, where do you get the IP address from? Any answer to this one? What is
Correct.
the solution to this approach?
Correct.
Okay, good. Exactly. Good question, actually. So we had thought about this, and the thing was, NLBs over here, if you see, 1A is forwarding to a elastic IP, and this is the IP, right? So even though tomorrow, if my load balancer is destroyed, Ravi, my IP address remains, right? Elastic IP
Yes,
never goes
correct.
from me. So I will create the new load balancer and I will attach this elastic IP to that specific new load balancer. That's it. Okay.
Okay.
Ankit, how
Oh.
does the capacity reservation is different from the load balancer diagram?
Very different. Capacity reservation is about instances. Load balancer will forward the request to the instances.
Okay,
Load
so
balancer is like your manager. Capacity, okay, consider it like this. You have a developer and you have a contract on the developer. You can't leave with the you cannot leave for 3 months. Load balancer is the manager. That is a separate thing. You don't have any contract on them.
okay, so capacity reservation is associated with a instance itself.
Only instances, yes. That is why anyhow, no, you saw it inside instances. Maybe I confused you by giving you that example. Sorry for that, but just understand capacity is only for instance, not for load balancers.
Okay.
Okay, one thing I didn't tell you, by the way, let me tell you that also pretty quickly. I told you that what if someone created a CLB like this, right? In that case, how do you migrate? Pretty easy, actually. Create. So means our load balancer can even work without a instance also. There is no importance that you should have an instance. Any point of time, you could have always gone and added an instance later also. Edit, you can add it or remove it also if in case you have. So how to migrate? Very easy. Click on migration, click on launch and click on create. Done. A load balancer or a classic load balancer automatically changes to application load balancer. Though by now you would have realized a CLB and ALBs were doing the same thing anyhow, right? So anyways, you could have gone to load balancer and you could have done that. But remember, a classic load balancer, no, on the other hand, means it had a IP address, but that IP address was not associated to elastic IP. So Ravi's question, no, that, okay, you forwarded it to a NLB, fine. I understand IP address. What if you had forwarded to a CLB? In that case, I don't have a solution. CLBs or the network interfaces don't have elastic IP attached. Or even if they have the elastic IP attached, in that case, your machine's A record was pointing to that IP address. Their A record has to change, which means a downtime will be there. Or else use route 53 for provisioning. In that case, you are not pointing to IP address, rather you are pointing it to a load balancer, and that load balancer, you are pointing it to the endpoint of the load balancer. And remember, endpoint was forwarding to 3 IP addresses, right? So that was also, but
So
yes,
how
some
does
downtime will be there. Yes.
how does the stickiness maintained by the NLP that we have
No,
seen
they
the
do it automatically. You
Okay.
don't control that. That is what I wanted to tell, that in Azure stickiness you can control. NLBs you don't have any option. Okay. Fine.
Actually, initial session I missed that one. Starting. What is the prerequisite for the creating the load balancer?
Instances at least you should have, no?
Yeah,
Or
yeah.
even if you
Instance
don't have, that is fine. Even if you don't have, that is also fine. You can create a load balancer without an instance also. Later
Okay.
point of time you add it.
Okay, okay. We need to
But
give the target group and
I mean, the
username,
recording, if
right?
you see, you'll understand. Yes, TGs and those things. Yes.
Thank you.
Fine. So let's leave it over here. I wanted to do auto scaling today over here, but